As we discussed about superconductivity in the last video lesson, I just want to show you a video which is explaining superconductivity with the help of pictures. Hope you'll understand it clearly. Let us watch and listen carefully.
What is a superconductor? The present age is the age of electricity. We use electricity to light the lights of our houses, streets, etc. Devices like television or a computer, etc. operate with the help of electric current. Thus, electricity plays a very important role in our daily life. When we analyze the devices which operate on electricity, we find that some amount of electricity is always lost in the form of heat. Let us discuss how. When we analyze the devices, we find that they are composed of vibrating positive ions and free electrons. These vibrating positive ions offer resistance to the flow of free electrons in the form of collision. This causes the loss of energy in the form of heat. Note that about 20% of electricity generated worldwide is wasted due to the resistance of wire and device. So you can imagine how much electricity we can save if we can reduce the resistance of the material. In 1911, Dutch physicist Heike Kamerlingh Onnes discovered that under certain conditions, some materials do not show any resistance. Such materials with zero resistance are known as superconductors. Thus, we can say that superconductor is a material that has zero electrical resistance. Let's now discuss the condition under which the material shows the property of superconductivity. When we keep decreasing the temperature of a material, we see that the free electrons stop colliding with the ions. As a result, the resistance of the material also decreases to zero, and it starts behaving like a superconductor. The temperature at which the electrical resistance of a material drops to zero is called critical temperature. Let us now analyze the behavior of a superconductor when placed in a magnetic field. When we place a superconductor in the magnetic field, we see that the magnetic field bends around the superconductor as it is not able to pass through it. Thus, the superconductor behaves like a perfect diamagnetic material. Now, if we keep increasing the intensity of the magnetic field, we see that a stage comes when the magnetic field penetrates through the superconductor, thus destroying its superconductivity. The magnitude of magnetic field at which the superconductor loses its superconductivity is known as the critical magnetic field for a superconductor. It is electricity.
Hey guys, welcome to SkillLink. The invention of electricity changed our lifestyle and it has become an integral part of our life. We depend on electricity for so many jobs and cannot pass a day without it. You might have noticed electric equipment getting heated up after prolonged usage. This heat is generated because of electrical resistance. This implies that there will not be a loss in the form of energy when there is no resistance. But are there elements that exist without electric resistance? Well, you'll get to know the answer in this video. In this video, we're going to discuss what is superconductivity, what are superconductors, their properties and applications. So let's get started. Materials can be divided into three main categories based on their electrical conductivity. There are conductors which conduct electricity and insulators which do not. Then we have semiconductors that can be made to conduct electricity. The conductivity of a material is due to its internal structure. In a conductor, the electrons are loosely bound to the nucleus so that they can move easily when there is a potential difference. But as the temperature increases, the positive ions in the conductor start vibrating due to thermal stresses. This in turn interrupts the flow of electrons, that is, it resists the current flow. It is noted that the increase in temperature increases the resistance of the conductor. Studies were also made to check if there are any materials that exhibit zero resistance by lowering the temperature. In 1911, a Dutch physicist named Heike Kamerlingh-Onnes discovered that mercury at a very low temperature of 4.2 Kelvin conducted electricity with almost no resistance. Following this, some other materials that also conducted electricity with zero resistance when they are at extremely low temperatures had been found. This phenomenon by which materials possess zero electrical resistance at extreme cold conditions is known as superconductivity, and the elements that exhibit this property were called superconductors. The temperature at which a conductor turns into a superconductor is known as the critical or transition temperature, and this varies from conductor to conductor. Now let's see how superconductivity actually happens. Though the phenomenon was found in 1911, the reason behind that remained unknown for years. However, in 1957, three scientists named John Bardeen, Leon Cooper, and John Robert Schrieffer came up with a theory called BCS theory, which explained the phenomenon of superconductivity. Let's see what the theory says. Consider that we have a superconductor. Due to the extreme cold condition, the molecular vibrations are negligible. For instance, let's take a single electron which travels towards the positive terminal through the positive ions. As the electron moves, the positive ions are attracted towards it because of the opposite charge. This in turn results in the accumulation of positive ions in a place, for instance. This increased positive charge attracts secondary electrons towards it. That is, the electrons form a Cooper pair bound together by a weak bond. The Cooper pair is bounded over a long distance and moves together towards the positive terminal. The number of Cooper pairs overlap each other and move together between the lattices without causing any disturbance, resulting in zero resistance. Because of the zero resistance, the current can flow in a superconductor loop even after the source is removed. Apart from zero resistivity, superconductors also have a significant feature. A superconductor is completely diamagnetic as it expels magnetic fields. That is, when a normal conductor is placed in a magnetic field, the magnetic lines pass through it. But superconductors repel the field and it will not have any magnetic field inside it. This effect is called the Meissner effect, and because of this, superconductors are used in levitating trains. The fast-moving maglev train consists of superconductors on its base which repels the magnetic tracks. This ensures fast movement with minimal power loss. But superconducting property is not permanent. The material can lose its superconductivity when a large current or another magnetic field of high intensity passes through it. The minimum current density at which a superconductor turns into a conductor is known as the critical current density, and the minimum intensity of magnetic field at which the material loses superconductivity is known as the critical magnetic field. So far, we've talked about superconductors that are categorized into type 1 superconductors. But there are also some materials that exhibit superconductivity at a high temperature. Those materials are categorized as type 2 superconductors. However, the reason behind the superconductivity at high temperature is still largely unknown. Preferred mainly because of their zero resistance, low power loss, and capacity to produce large magnetic fields. But major disadvantage is that they cannot be used in ambient temperature. When it comes to applications, superconductors play a vital role in so many applications. They are used in MRI scanning systems, computer parts, particle oscillators, power transmission elements, power storage elements, etc.